The purpose of this build is to satisfy the many inquiries I've received from the community about building a 6th-order bandpass. Furthermore, I've always been curious about the structural design of a series configured 6th order versus that of a parallel configured 6th order. I mean, after all, one you daisy chain the ports together, and the other they individually fire into the environment. So, in common sense, you should be able to use the same internal volume specifications for one for the other. I mean, after all, they're both 6th order bandpasses. Well, as you guys may already know, based upon the thumbnail and title, this turned out to be a lot more difficult than I expected. So hopefully you guys will stick around to the end of the video and see exactly what I had to deal with when constructing this 6th order bandpass. In other words, learn from my mistakes. The goal of this build is to successfully construct a series configured 6th order bandpass using software I have formerly used to build parallel 6th order bandpasses. So now that you know the purpose of the build and the goals of the build, what is the purpose of this video? Well, in a recent post, I shared with you guys that I had failed miserably at an attempt to build this enclosure. And despite my shame and honesty to you guys, you still strongly suggested that I post this video. And since it's my responsibility to give you guys what you request, in this video I will show you exactly what not to do when building a series configured 6th order bandpass. Over the years, I've learned that it is best to design my projects in a digital space first. That's before spending all my hard-earned money on building materials and such. To be more specific, you can design sealed enclosures, venting enclosures, and bandpass enclosures with this program. You simply input the subwoofer's TS parameters, and this program automatically calculates many values for you. In our case, we have designed a 6th order bandpass enclosure using a single CT Sounds MESO 6.5-inch subwoofer. Our final design has a rear chamber with an internal volume of 1 cubic foot, and it has a tuning frequency of 30 Hertz. And with our front chamber, we have an internal volume of 0.1 cubic foot and a tuning frequency of 50 Hertz. And once we have the measurements for our port area and port length of each chamber, we can then start the modeling phase of this enclosure using Sketchup. Sketchup is a free software that you can use to render 3D models of your subwoofer enclosure. You simply use the dimensions suggested by WinISD Pro and begin shaping an enclosure based upon your space. But what is a 6th order bandpass enclosure anyway? And how exactly do they work? Well, first, let's talk about a base reflex enclosure. Because traditionally, a ported enclosure produces sound by building up pressure inside its cabin, which is then forced through a port, which in turn is tuned to a specific frequency. This type of enclosure is known as a base reflex design. In contrast, a 6th order bandpass enclosure have 2 ported cabins in which pressure is built within, and depending on configuration, the ports can be connected in series or independent of each other in parallel, hence parallel and series bandpasses. To simplify this, it's kind of like merging 2 ported enclosures for a single subwoofer.
Wow.
For this build, I chose to go with MDF. Yeah, it's a lot heavier than plywood, but it also has a superior sound signature. I used 3/4 inch MDF for the top and bottom and also the baffle, but all the walls were constructed of 1/2 inch MDF, just to keep the weight down. I then simply followed the cut guide developed in SketchUp and soon had a flat pack to assemble. I only use glue and brad nails for my build and large clamps to keep everything in place. And once everything has dried and all the clamps are removed, this is what you should be faced with. One of the main downsides to demoing a bandpass enclosure is the fact that everything is concealed. So in order to give you guys a visual aspect to this demo, I chose to make the top out of plexiglass. Now keep in mind that the plexiglass is only for visuals and is not for structural integrity. This plexiglass is very, very expensive, so I pretty much got the cheapest and thinnest piece I can find. And the main reason that I'm pointing this out, other than obviously it's not a wood top, is that if you plan to do something like this on your own time, this stuff is very, very dangerous to cut. So I wanted to kind of give you guys a forewarning on protective measures to take while doing so. First and foremost, please use the correct blade when cutting this stuff, and also have you some protective gear. This stuff flies everywhere and is basically melted plastic, hitting any exposed skin that you have above the table. I strongly suggest getting a full face mask for this type of job because this thing kick chunks everywhere. There are other types of tools of cutting this stuff as well that includes utility knives and such, but in my case I had a table saw and I had the correct type blade, so I went for it with the tools that I had. And as you can see from the video, my arms were completely covered in this stuff. So just make sure that you have all the safety attachments to your table if you're going to be using a table, and stay safe in the workshop, guys. Alright guys, so right now I'm doing some testing of this enclosure, and let me turn this off. And I must be honest with you guys and say that this enclosure, as it stands right now, is a complete fail. Yep, I gotta let you guys know stuff when it goes on. I tested it over here in the app like I always do. Give it a base sweep, see where it peaks, see if the peaks are matching, you know, what the software tells me. And in this case, it is not. Program gives me tuning for a 6th order bandpass only in what I consider parallel configuration. Okay, so if you go to WinISD, which is, this is what I have up on the screen right now, this is a parallel icon. My inner chamber is my 30 hertz chamber. Okay, this outer chamber right here, the front chamber, is actually tuned to around 50 hertz, 55 hertz or so. You know, if you want a 60 and a 30 hertz port, does it matter if it's in series or parallel configuration? That was the whole point of the video. I know you guys didn't know that, but this is part of a series involving the CT Sounds 6.5 inch subwoofer. I'm thinking maybe the program gives you calculations only for parallel. I don't know. In my mind, it should work either way. You more experienced guys may know better. But the second thing that I think is going on here is I think that this center bracing right here, you know, despite being 6.5 inches in diameter, I think this and this is now 2 separate chambers instead of it supposed to be in 1 chamber. I think I need to remove that bracing. The 2 peaks it's supposed to have is at 30 hertz and at 50 hertz. But this thing is giving me a peak at 50 and it's peaking at like 90. Something crazy like that. I'm gonna take this hammer and I'm gonna knock it out of there. I'm about to probably wake up my whole household right now. So, wish me luck. Man, I hope that really works, because if not, I just ruined a perfectly good window. Alright guys, so what you guys are looking at right now is the same test enclosure, but what I've done is something a little bit unorthodox. I haven't done this before, which is I've gone in and placed confetti within the chamber. So why would I do this? I want to see how is the air flowing throughout this enclosure? Now, I told myself I wasn't even going to show you guys this, but I have to. I'm still in the phase of testing this. Right now, I have my tone generator set at 20 hertz. I'm going to play that tone generator, and I'm going to give this thing some power and bring you guys along on this test. I want to see the confetti move, and I want to see at what frequencies it's doing is moving, because when the confetti moves, that means pressure is actually being built up, and it's actually forcing it through the port somewhere. This is completely like on the fly stuff, man. So just bear with me, guys. As you guys can see, the subwoofer is receiving a 20 hertz test tone. And I don't have all the screws in here, but please be mindful that that's an airtight seal, guys. See how flat that is? Ain't no air getting through there, so I don't want to hear anyone in the comments talking about that. No air is flowing because none of these chambers are tuned to 20 hertz. So let's bump them up, and I'm going to show you guys the response that I've been getting here, which is horrible. I'm going to move it up to 25 hertz. That's 25 hertz. That's 30 hertz. And I'm getting a little something, but not a lot of sound. Let's give it some juice. So it was on 20. I'm gonna put it on 25 and see if you guys can notice any confetti moving around. You see that? More confetti. You see it? Dancing confetti. That's what you want to see. That's what you want. That port is activated. I know I don't always bring you guys in on this type of stuff, but this is how I test. My whole thing is why I can't hear no sound coming out this damn thing. Let's keep going though. 35 hertz. You see that? Even more activity. In that port. Nothing from the 50 hertz yet. The 50 hertz chamber is doing nothing. 40 hertz. That's 40 hertz. And the 30 hertz port is really going crazy right now. Of course, the higher the frequency, the more power the amp is going to put out. It's blowing pretty good at 40 hertz, which to me is odd. You see, it's even kind of activating this port now. See this? Look, this port is having more activity. I'm gonna show you why in a minute. Because, and you see that 40 hertz. Now watch that 45 hertz. Crazy stuff. And yeah, I got some flex in the center there because I took the brace out. That's the original brace I took out of the center. But now this thing is going crazy at 50 hertz. I mean, 45, sorry. I'm not gonna edit none of this out. 50. 50 hertz. And that port is going bananas. Now all the ports going bananas, especially over on this outer port. I mean the inner port, of course. See that chamber? I'm sorry. Give y'all some more light. See the 50 hertz chamber? That's what it's supposed to do. All right, so let's go to 60. You're gonna see a drop. This is your dip. That's 55. Right? $60. But watch this, I'm gonna go all the way up to 100. Listen to the sound at 96. Ridiculous sound coming from that. And look at this port at 96. That's crazy. That is crazy. Oh, that's crazy. To me, I don't know what the hell going on with this thing, but it loves 90 and around 50. That's what it likes. This is not a waste of an enclosure. It's just not tuned to the type of music and sound that I like. I like R&B, hip hop, blues, stuff like that. This is good for like rock and roll music because it's way up there. Kick drums and stuff like that. That's what this thing is good for. It's not good for my type of music. All right, guys, so I'm trying my best to salvage this build. I still think it has some potential, and I think I can save it. What I'm going to do is seal off this chamber right here. I'm going to seal this off. So essentially, it's going to become a fourth order, okay? Not my original plan at all. But to learn something from this mistake, which you're always supposed to do, I'm going to go ahead and I've taken some project foam here. You see that? This is what I'm using to seal the port off. And you guys can see all the way to the floor of that. And at the rear, turn you guys around. It's sealed pretty good. This is 3/4 inch foam. Very easy to cut, leaves a mess. But for this project, I think it'll do very, very, very well. To level it off, I'm going to just, keep it flush and pretty much just cut like you see me doing now. So that's pretty much what I'm going to be left with. This does have compression. You see that? Even though I took a hammer and beat that thing in, but it's just going to give it an even better seal from there. All right, guys, so we're back here in the lab, and as you guys can see, that is great compression right there. Really, really good compression. Very satisfied with what I see. And now I know that this section, which was originally the 30 hertz section, is now completely sealed off. So essentially, this is a fourth order bandpass now. Okay, the frequency tuning of the sealed section at 1 cubic foot is going to be 60 hertz. This section here now is with a tuning frequency of 48 hertz. So you have 48 and 60 hertz. Okay, now what we're going to do is run a bass sweep from 150 to 20 hertz. Okay, so I got you guys at a different angle now to try to get you guys a better view of the confetti. Now keep in mind that we're focusing mostly on the outer port, this port on the outer parameter that is connected to this chamber. Give it some volume. I don't see a lot going. Okay, here we go. 20 something hertz. Wow. This thing seemed to be peaking at like 20 something hertz now. This is crazy. Watch this. Look at this. I swear to God, y'all, 22 freaking hertz. How in the hell, how is that even possible? That's the new tuning frequency of this thing? Even more power. Look at this. Even more. I can feel it all in the room and through the floor. I can feel it all in the floor. This is, man, to me, this is such a rewarding experiment. Oh my God, that is beautiful. Even more. That is bananas. Oh my God. How do I now have 30 hertz? From 35 to like 20 hertz. That is crazy. That is crazy. I'm so excited for the fourth order build. I wish this was my fourth order build, but I mean, you guys know it was supposed to be a series tune sixth order, but man, I just learned a whole lot. All right, guys, so we right back at it. Now, as you guys can see, I have gone and stuffed the chamber somewhat. The goal or the objective was actually to reduce this by 3/4. I want to only give it a 1/4 cubic foot. Okay, so I've taken some project foam board. So what I'm going to do now is I'm going to do the sub test. Okay, so here's the bass sweep from 150 down to 20 hertz. All right, so as you guys can see, it's way more responsive than it was at first. This thing is playing all the way down into the 30s. So you got a response now of around 60 something all the way down to 30 something. Now we just seen the response of this, which is okay, but what does this sound like on music? While playing music, you wouldn't know whether this would be an enclosure for you. What music genre would actually sound good in this enclosure? Up. Alright, so that's it for the music test. I like what I'm seeing here. I don't like the fact that I wish I could have got it right the first time, like any engineer would. But the learning experience here is priceless. You know, there is no dollar amount you can put on the lesson learned in this video right here. And I will take that into every build thereafter that I put into, whether that's a horn enclosure, simple bass reflect enclosure, fourth order, sixth order, whatever it may be. I would take the lessons learned here and apply them next time. for visiting the channel to help you simplify car audio. It's the Budget Basshead, and I'm out.